So this separate movie is just how I would have done one of these calculations. I'm completely leaving it up to your teachers whether they give you this and when they give you this, because some teachers would explain things in a different way. But anyway, let's go through what we had. We had 0.0982 molar HCl. We've had 0.0993 molar sodium hydroxide. I weighed out 0.1396 grams of the antacid. I added to that 25 cubic centimeters or 0.025 cubic decimeters of my HCl solution. And remember that neutralized all the calcium carbonate in the antacid and left some HCl over, which I then neutralized that leftover HCl with 7.2 cubic centimeters of sodium hydroxide, which is 0.00720 cubic decimeters. Now remembering, molarity or concentration is moles of the solute over cubic decimeters of the solution. I can figure out that moles of solute is molarity times cubic decimeters. So the moles of HCl is the 0.0982 moles per cubic decimeter. That's the concentration of the HCl times the 0.025 cubic decimeters that I added, or 0.002445 moles of HCl. So I took my antacid and added 0.002445 moles of HCl to it, neutralized all the antacid and left some HCl over. Determined how much of that HCl was left over by taking moles of sodium hydroxide, 0.0993 moles per cubic decimeter, times the volume that I needed to titrate, 0.00720 cubic decimeters, or 0.000715 moles. Okay, now remember the reaction is 1 HCl plus 1 NaOH goes to NaCl plus H2O, so in other words neutralizes it. So in other words, because I had to have 0.000715 moles of NaOH added, that means that I had 0.000715 moles of HCl left over after the neutralization. Putting those moles of HCl together, that tells me that I used up 0.00173 moles of HCl in neutralizing the base in the antacid. Now, of course, that base in the antacid was calcium carbonate. I need 2 moles of HCl to neutralize each moles of calcium carbonate. So therefore, the moles of calcium carbonate that were in this antacid was the moles of HCl used, 0.00173 moles, divided by 2. Or 0.000865 moles of calcium carbonate. Now, calcium carbonate is a lovely substance in many ways, but particularly because its molar mass is about 100 grams per mole. So 0.000865 moles of calcium carbonate is 0.0865 grams of calcium carbonate. So in other words, in this amount of the antacid that was the calcium carbonate plus filler, 0.00865 grams of was the calcium carbonate. So the percent calcium carbonate is the amount of calcium carbonate in the antacid divided by the grams of the antacid times 100, or 62%. Hopefully that helped with the calculation. Hope you enjoyed the lab. Hope you will do my next one, which will be out in about a week.